So Chapter 4, recap. There's two packets that we had. This one is rational functions. First thing we're going to do? Yes, let's factor. The bottom looks nice and fun. X plus 5, x minus 5. The numerator is definitely x and x. How do we make a 3? Minus 3 minus 1. Okay, so I'm looking at this rational function. And let's state the domain before I cancel anything out. All reals except not plus or minus 5. Are there any holes here? No. How would you know if there's a hole? If something canceled. And you take that number, and how do you find the y value? Plug it into the new equation. Okay, but we don't have any holes here. Are there any vertical asymptotes? Yes, at x equals plus or minus 5. So let's go ahead and get those asymptotes drawn. Negative 5, positive 5. Okay. End behavior. Let's take a look at the powers. I noticed that the powers are the same. So it's y equals leading coefficients 1. Oh, just for fun. What if it was bottom heavy? Then it would be y equals 0. What if it's top heavy? Oh, long division. What does oblique mean? You'd get a diagonal line, so your long division answer might be x plus 5. The top one would go in the divide box, and then the small one would go out there. Okay, how do you find an x-intercept? Let y equal 0. Yeah, but the faster way for these would be just to look in the numerator. Okay, so I've got one at 3, 0, and one at 1, 0. Okay, 1 has an x-intercept, and so does 3. Now be careful when you're taking a multiple choice test. Okay? Oh, I look in the numerator. So I just look real fast at the numerator. Except what if it cancels? Is it an x-intercept anymore? No. Same thing with vertical asymptotes. Sometimes people do bad on multiple choice tests. Oh, vertical asymptotes, I'll just look in the bottom. But what if one of those cancels out? It's not a vertical asymptote, right? It's a hole, okay? So you should look at numerator and to make sure you pick the right multiple choice answer for these. How do you find a y-intercept? Let's put 0 into the x spot. I like to look at the original problem. Just cross out all the x's. Negative 3 over 25. It's really tiny here on the y-axis. Oh, I forgot to draw the asymptote, the end behavior. Can you cross a horizontal asymptote? Yes. Can you cross an oblique asymptote? Yes. All the end behavior ones are there for the ends. Can you cross a vertical? Never. All right, let's put your pencil on this point right here. Let's aim for this point, aim for this point. Okay, now what? All right, let's go down, down, down on the left. So, up, up, up on the right. Okay, a vertical asymptote will make the graph split. Let's go ahead and follow this over here. All right, so I've got this graph. Should I go up? I know I can cross a horizontal, so that's not a problem for me. Does it have any x-intercepts there? Do not touch any other place on the x-axis. Okay, so down, down, down on the right. So I'll go up, up, up on the left. Okay, drawing a rational graph. Now you're not going to be drawing anything on the final. You're going to have to find it. So knowing how to calculate this information is actually going to be way more powerful. And you guys did a really good job on the test on the rational graphs. Okay. When you did the polynomial chapter, a couple of the hints that we always looked at. Can you just factor by hand? Can you just get this thing factored? I don't think so, but always stop and look. Okay, if you can't factor by hand, let's make a PRZ list. Plus minus 1 plus minus 3 comes from the constant all over, not always the answer, all over plus minus 1. Okay, so I don't really need to consider anything. The first one that I'll test is 1. You have to make sure here you add your oxes. So I've got 1 for the fourth power, 2 for the third power, -4, -2. All right, I did not need any oxes. Okay, synthetic division, we drop it down. 1 times 1, 1, 3. 3, -1. -1, -3, -3. It worked. As soon as you find something that works, let's write it in factored form. It says graph. In my last class, I didn't leave enough space, so I'm just going to kind of make some space here for the graph and make sure I go way over here. What's the factor that we found? X minus 1. Okay, so there's the factor. And then the quotient is 1 power less than the fourth, so x to the third plus 3x squared minus x minus 3. Okay. Should we keep testing? Oh, always ask yourself, hey, can I just factor? And grouping in this case does work, so yeah, let's put some brackets around this cubic. The great thing about the final is I'm not going to be looking at your step, line by line. So if you're not writing things perfectly, I guess you get a free pass this time. We'll take out x squared, and that leaves us with x plus 3. Minus 1 gives us x plus 3. I've got duplicates, so it worked. We've got x minus 1, x plus 3, x minus 1, x plus 1. Totally factored. Yeah. So where does it touch the x-axis? +1, -1, where else? -3. Oh, let's ask for some information here. Where does it touch the y-axis, Muncie? At 3, the best place to do that is just look at the original problem right here. There's your y-intercept. How about end behavior? How about end behavior? Oh, good. Okay, up, because it's a fourth power. Okay, so on the multiple choice final, if any of the graphs are going down, down, cross them out. If any of them are going up, down, cross those out. We're looking for up, up. All right, now I got to know what we're doing here. I'm approaching -3. What do I do? Cross it. I'm approaching -1. What do I do? Let's see. X equals 1. X equals -3. X equals 1. X equals -1. If I brush it, how am I going to touch up here? Should I brush it and then ride the y-axis? What's going on here? 1 time, we'll cross it. Y-axis. 2 times, oh, perfect, that matches up over there. Okay. Again, you're not graphing anything. You have to find the graph. Once you find the x-intercepts, look for the one that brushes in the correct place. Why do we brush 1? Oh, that's the y-intercept. That crosses the y-axis. Yeah, we never brush the y-axis. You just have 1 y-intercept so that it's a function. Okay, so polynomials were something that we definitely studied. What do we got on the next page here? When it says polynomial, what does polynomial mean? It means many terms. So how do you make many terms? You have to multiply it out. Multiply it out. So a lot of people forgot to multiply it out on the test. I guess if you see the answer choices on the final, you'll know, oh, I got to multiply it out. We also have to remember the buy one, get one free rule. If it tells me 3 plus 2y is a 0, they're also saying 3 minus 2y. So they gave me 2 of the zeros. All right, let's make the polynomial here. F of x equals leading coefficient of 2. Okay, and now I've got to say x's. So we're going to say x minus 3 minus 2i. And I'll do the next one here. X minus 3 plus 2y. Now let me just stop and talk about all the change. Do you see buy one, get one free? We only do one change, the a plus or minus the bi. That's the one that you change to the opposite, right? Now here, you do change. You change both of them to the opposites. Anyone have any questions on all these changes? Here you make one change, here you make two changes. Now I have to remind you of the a and the b trick. We have to multiply this out. So the a thing that they both have is x minus 3. And they both have a b thing, which is 2i. So the first set of parentheses has a minus b, and the next one has a plus b. So I'm going to multiply it out with that trick. 2, you just have to wait till later. I have to do a squared minus b squared, right? The a thing squared is x squared minus 6x plus 9. Okay, so I already wrote that down. Now we have to write down the minus sign. I'll put the minus sign right there. Okay, now let's work on the b thing. Some people messed this up on the test because they didn't actually do 2i times 2i. 2i times 2i is 4i squared. Some people said 2. They just did the I part. Hey, when I say I squared, you think negative 1. So negative, that's going to make a positive, right? A positive 4. So f of x equals 2x squared minus 12x. This is plus 13, so it's going to be plus 26. Now, if you have a lot of extra time on the final, don't turn it in early and then hang around. Did you know that you could take this quadratic, do the quadratic formula, and solve it? You know what the answer should be? Right there, yeah. Those should be the answers. If you do the quadratic formula, you should get those two nice answers. You'll get a negative in the radical. All right, if you have a lot of time. We studied everything forwards and backwards. So you could check every problem that you do backwards and forwards if you've got a lot of time. Okay, number 4. How do you solve an inequality? Step 1. You got to make a 0. Does this pen work? Or is that too limey? Kind of limey, huh? All right, I got the 0. And now we're adding and subtracting fractions. I say fractions, you think common denominator. So the denominator between x's and 1's is x. I've got to make all the denominators x's. The first one needs x over x. The second term already has the common denominator. This last one also needs to get x over x. So the common denominator is x, and the numerator is x squared minus x minus 12. Guess what we got to do, people? Factor. It's got to be x and x. How do you make 12? Negative 4, positive 3. Okay, so we've got it factored. We made the 0. All the terms are together. Now it's time to draw that number line. Okay, let's do something fun. What if there was a 5 out here? What number would go on the number line? If there was a 5. Okay, let's go see. Let's take this over here and say 5 equals 0. No, it doesn't. What number goes on the number line when you have constants? Nothing. You only do it for x's. Here, I'll show you again. Let's take this one. X minus 4 equals 0. So what number goes on the number line? 4. So we've got 4. So you look for x's. We've got negative 3, and we've got 0. All right, 0 came from the bottom. So what should we use? Open. How about the 2 from the numerator? Is it always closed? Depends on the sign. Depends on the sign. All right, we'll take turns here. Guys, test this section. Girls, test this section. Guys, pick a negative number. Really, really big. Girls, pick a negative number small. What? That's 1 vote. 2 votes. It works? Okay, guys are saying this section works. Great. Okay, girls, does yours work? No. Oh, too bad. Okay, guys, pick this little section. Girls, take the big section now. It works. This one here? This was boys, this was girls, this was boys, this was girls. Boys, does yours work? Yes? Again? Oh, lucky duckies. Girls, did yours work? No. Okay, so again, I'm going to put the answer in either inequality or interval notation. You've got to find the right answer after you test the sections. Okay? For people that have like a lot of time on their hands, if you've, oh yeah, I just, oh, who's got that? If you've got a lot of time when you take my test, you could always draw a graph. You could draw a graph. This is a rational function. Where's the vertical asymptote? 0. Where's the x-intercepts? Yeah, -3 and 4. Okay, remember, those are critical values. Something happens there. It's top-heavy, so it's going to have an oblique asymptote. So this is how the graph looks. It goes like this, like this, like this. Again, who's got time to draw this graph? But you could look at a graph, because where is this rational graph less than 0? Where is it less than 0? See these things right here? -∞, -3. And then between 0 and 4, it matches what we did there. People don't like drawing rational graphs. It takes a lot of time just to get the answer. But we also did this with parabolas. You could either do a number line for a parabola, and then remember how we did parabolas like this? And I said, where is the parabola greater than 0, or where is it less than 0? Okay, so you could draw graphs, or you could do number lines. It's the same thing. And the last thing that we did in Chapter 4 was partial fraction decomposition. 4 types. 4 types, but the step 1 was always the same. Factor the denominator. Take out x squared, that's x minus 3. Take out, well, let's take out a 4, and then I'll get x minus 3. Perfect. So x squared plus 4 and x minus 3. Can that factor any more? It can't factor anymore. Irreducible. That's an irreducible quadratic. So if you're stuck as a quadratic, do you know what he needs as his numerator? Ax plus b. Okay. This one got factored all the way to linear. What do linears get? Just a constant. Let's put the numerator over here. Okay. What happens? What if I had one of these factors twice, like repeated? Once is a single, once is a double. Now don't get scared, because if you have to write him as a double, does that mean he's quadratic? No, it's a repeated linear. So look over here to see how far was I able to get factored, and then that will help you determine your numerators. Then we're going to take the left-hand side common denominator and multiply all the terms. Okay, so on the left-hand side, it's always just the numerator. When I distribute here, the quadratic quantity cancels, and ax plus b times the x minus 3 quantity. Distributed to the c, the x minus 3 cancels, but you have the quadratic. So step 1 and 2 are the same for all the types. Now, if you have a good x, you should use it. What if you have no good x? Then you multiply everything out and you match it up. Remember how you match up the constants? Do we have a good x? Yes. How do you know? You look at your factors. Are there any x-intercepts? There's a 3. Okay, so since we have a good x, we have to go with that technique. So we're going to let x equal a 3. If it doesn't have a good x, then you have to multiply it out and match it up. All right, left-hand side. 9 times 5 is 45. Minus 9 times 3, 27, plus 8. We'll do numbers in just a second here. When x is 3, 3 minus 3 is nothing. What happens to all these things here? Okay, cancels out. And then c, 3 times 3, 9 plus 4 is 13. All right, who can do basic numbers? 45 minus 27 plus 8. I got a lot of people with big eyes hoping someone else does it. I got one person that did it, one person that believes the person that did it, and everyone else is just sitting around. That's what you got? Big eyes, yeah? You actually did it? Huh? Oh, look around. Everyone's just kind of staring at me. What's that guy doing? Huh? They got 26. Concur? 26? All right, let me ask you guys a question. If you go to divide by 13, and you have 26, is this seeming like it might be the right answer? What about 28? When you get something like this, do you say, let me just go add those numbers one more time? Good. Okay, so 26 and 13, this is looking really nice. I get it too. All right, let's pick the next good x. I think we're out of good ones, right? Let's pick an okay one. 0 is a really nice one. On the left-hand side, I got 8. A times 0 is nothing. I've got b times negative 3 plus c times a 4. Oh, man. I can't find the letter because I've got too many variables here. Oh, c will have to help out. So let's change that to a 2. So b is... Thinking? 0. Good, 0. Okay, let's pick the next okay x. Let's use, we haven't used 1. That's a nice small number. 5 minus 9 plus 8. 4? Okay. Do you know that these other two numbers are going to have to help out? Okay, let's use them right away then. A times 1 is A, plus B is nothing. 1 minus 3 is negative 2. C, come help us. That's a 2 and a 5. Well, until you get all your letters. Well, actually, that's a lie, because this is a multiple choice final, right? So after you found C, what you might want to do is put 2 up here, right? Put your 2 up here, and then look at your multiple choice answers. Does any of them have a 2 on top of x minus 3? It might be able to pick the right one. Then you take 0 for B. Okay, let's put a 0 here. Is there any multiple choice answers that have this? You might not have to go all the way on the multiple choice final. Remember how I put these on the test? How it was pick the correct setup, and you didn't actually have to finish all the work? So, be ready for something like that. Be ready for anything. Okay, let's do this, and do this. Stop this video.